Hi everyone, welcome to this Linaro webinar on long-term support for the Linux kernel. We'll be starting in a few minutes. We're just going to give people time to join. We've already got a good number of participants, but we'll just give people a few more minutes to join. If you're new to Zoom webinars, just check out the Q&A button, which should be on your app or on the interface, because we do welcome your questions. You can raise a question at any time, and we'll go through questions at the end. But feel free to raise a question as soon as it occurs to you, and then we'll work through them in order when we get to that point in the program. Hey, for people just joining, welcome to this Linaro webinar on long-term support for the Linux kernel. We'll be starting in a couple of minutes. Just give people time to join. If you're new to Zoom webinars, please check out the Q&A button, which should be on your interface. Feel free to raise questions at any time during the webinar. We'll get to them in the Q&A section, and we'll answer them in order. Thank you. We're just waiting for a few more people to join before we start this webinar. Just waiting for a few more participants. Okay, welcome to this webinar. We do seem to be pretty stable at a good number of participants now. So we're going to make a start. So a warm welcome to you wherever you're joining from to this Linaro webinar, long-term support for the Linux kernel, what's changing now. We will be sharing the materials for this webinar after it's been run. There'll be a recording and the slides. And we'll provide you with details of that at the end of the webinar. So thanks for joining. Again, if you have any questions, please raise them via the Q&A button as we go along, and we'll get to them in the Q&A section. So for this webinar, we are looking at the Linux kernel community support for the kernel, which is currently offered 2 years. There is an option for the community to extend that support, but it's only an option. And we ask the question in this webinar, and we look at potential answers as to whether that's enough for ODMs, silicon vendors, and solution providers who ship the Linux kernel. And to a certain extent, there's been an expectation of 6 years of support because of historical events, and now it's currently at 2 years. And also we ask the question, does long-term support apply to more than just the Linux kernel? We're obviously very excited to talk about the Linux kernel, but there are other potential dependencies. So with Linaro, our speakers are going to explore the issues, and we're going to lay out how commercial organizations operating primarily in the ARM ecosystem can satisfy needs. And one thing that we're particularly going to look at is the requirements of new government mandates. To that end, I'd like to introduce our speakers. I'm Bill Fletcher, Solution Director at Linaro. I'm the moderator for this webinar. Our two technical speakers are Dan Carpenter, our LTS kernel architect, and Tom Gall, our Director of Virtual Technologies. So before I hand over to Dan and Tom, once again, if you have any questions, please feel free to raise them at any time during the webinar. Tom, Dan, over to you.
All righty. Thank you, Bill. And thanks everyone for joining us today for this webinar. So let's get right into it. So the subject for today is, of course, all about long-term support. And there's a number of factors that are causing it to evolve. Throughout the agenda today, we'll look at some of the community and governance dynamics that you want to be aware of. We'll spend some time considering what makes a good LTS, and last, we'll close the webinar out covering what is Linaro's LTS solution, and we'll primarily try to keep the webinar to about 30 minutes, followed by about a 15-minute Q&A period, depending on how many questions that we have. So with that, let's move on to the next slide. Okay, so let's first start things off by defining what is long-term support. Long-term support, or LTS as it's commonly found, is really a concept that's found in some, but not all open source projects. The idea is that the project has a mainline development tree where developers are free to land new features, make changes. They may break the ABI, but really they're doing all the things that evolves the project in a positive, healthy sort of way without restraint. Whereas parallel to that is the concept of a stable version that's branched away from mainline development. And so in this insulated environment, the stable branch it's supported for a certain period of time, which really gives it the term, why it's long-term support, but it only is receiving fixes. At least that's, generally kind of the community accepted concept, fixes only. And these fixes, they are something that come from the mainline version of the development branch. So it's something where they will first land in mainline, and then they'll have to be backported to the stable tree or the LTS tree. So the graphic down at the bottom is really trying to illustrate this concept of having a mainline branch, an LTS release that's made off of that branch, and then fixes, which are backported, so thus for the backwards arrow that goes back into the LTS tree along the way, as communities discover and find things that need to be fixed and addressed in that stable branch. Another thing to keep in mind is that when you have more than one of these branches, for both mainline and an LTS release, or perhaps even more than one LTS release at a time, it does consume resources from the purposes of the project. The project has to devote time to author patches, they have to review those patches, they have to do some amount of CI, and they have to perform triage against the work. So let's move on to the next slide. Let's take this now concept of an LTS into a specific project. In this case, the kernel in particular, the Linux kernel. And so this graphic is trying to illustrate the community process around LTS. Patches flow in from a variety of different places. It might land in a subsister maintainers tree. They might be Linux Next, but ultimately when the code is picked up, it finds its way in Linus Torvalds tree in the mainline Git branch. Some of these patches that are added, they're new functionality, some of them are fixes, and some of them are addressing critical secure vulnerabilities. But the point is these fixes have to flow first into the mainline tree. Once it's found its way into the mainline tree, then this is where the Linux stable maintainers, so this is Greg Cage and Sasha, what they're going to do is they'll gather up a set of candidate fixes, and they're going to post those candidate fixes for feedback. And they set a 48-hour window for the community to basically respond as to the quality of those fixes. And so there are several community activities which are specifically set up to test and validate and look for regressions in the fixes that are being introduced for LTS kernels. So some of these projects like LKQ, the Linux Kernel Quality Project, which is something that we've been working on here at Linaro since 2017. It's a project that we founded and that we run. CKI is another one that's of note. That's by Red Hat. And then, of course, there's Kernel CI, which is also of note. And that's something that is put together by the Linux Foundation. Each one of these is picking up, like I said, the patches, they're running them, and they have to build them for all the configurations that they're testing. They have to run those tests on the machines that they have or that they spawn out to, and then they have to bring back the results, and then they have to triage those results, and they have to report back. And like I said, it's a 48-hour window to do so. So that's a very quick turnaround time. Let's move on to the next slide, please. Okay, so as I mentioned earlier, and as Bill mentioned earlier, there's some change within the kernel community that is happening when it comes to LTS. So about a year ago, what happened was Sasha had introduced a commit. And so in this particular commit, there were two changes. Change number one was to downgrade the support period for the 5.15 kernel from 6 years down to 5 years. The second thing that was changed was 6.1 was downgraded from a 6-year LTS to 4-year LTS. And then associated with those two changes was a bit of a comment within that fix to basically say the nature of the fix is to say, we are going back to a 2-year LTS release and align with the EOL dates from the existing releases. So it was a statement of intent. However, while that was an intended statement, if we look at the latest LTS, which was released towards the end of 2023, that 6.6 release didn't come out with a 2-year release support period. Instead, it came out with 3 years. Okay, so the thing to keep in mind here is the kernel policy down at the very bottom of this particular slide. And it's stated as being a 2-year LTS support period by default. But as been noted earlier, it's just a guideline. It's something that the community, should they desire, can extend that period for a longer period of time, which is, of course, what we've seen with 6.6. Let's move on to the next slide. Okay, so we've seen what the community is doing to change some of its support periods, but there are other factors in play, and we need to take a look at some of those. So let's move on to the next slide, which gets us into what are an amount of government mandates which are starting to come together. So across the world, governments have started to get increasingly concerned with cybersecurity. There's been, of course, a variety of security incidents that have happened. These do impact, real end users in their daily lives. And so governments have gotten motivated to take action to create either policies or new legislation to address these cybersecurity incidents so that they don't happen in the future. Now, it's an evolving situation, and the laws and mandates and policies that are listed on the left, it's not a complete list. And some of these are draft, some of them are things which are fully published, and some of them are laws which are either going into effect or have gone into effect. But there are some common themes that we can tease out of these changes that governments are introducing. First and foremost is devices need to be secure. Second is that devices need to be maintained for a certain period of time. You can't just release a device and then never issue updates for it. And another thing, which is and it seems to be an important concept, is that within the support period for a device is that when a security vulnerability is found or an operating system, a new version of an operating system is released, that there needs to be a timer that gets started at the point when either the source code for the security vulnerability has been published or when the operating system has been released. And then for the devices that don't have that security vulnerability fixed yet, or the new operating system release, they need to have those things made available to them with a certain period of time. Lastly, there needs to be some sort of process that tracks what is going into a new operating system or what needs to go into a bundle of fixes. And there seems to be a standard which is coming together for that called Software Bill of Materials, or SBOMs. Let's go on to the next slide, please. All right, so now let's deep dive into a couple of specific examples. First is the Cyber Resiliency Act. It's draft EU legislation, so it is not in effect as yet. We don't know when the exact date when it might take into effect. It is still something that is subject to change, but it has been through a couple of rounds yet, and there's certainly been a great amount of feedback that the industry has delivered to the EU in its crafting. So as of late 2023, really what this Cyber Resiliency Act, or CRA, is trying to do is impose best practices within the software supply chain. It's has gone so far as to carve out for open source software a bit of a get out of free jail card, if you will, saying that they don't necessarily have to comply with the mandates within the CRA. But it does say if you get into commercial activity, then you have to be compliant with the CRA. It really puts the onus on manufacturers and makes them responsible for safe products through the lifetime of the project, which is, or lifespan of the product, which is looking to be about 5 years. Now, on the right-hand side, we come to the ecosystem mandate, and this impacts handsets. It specifically says 5 years of support, it needs to be in place for a device. That includes operating system updates and security updates. It sets the expectation when there are security updates that that timer from when something is released, the vulnerability, and the fix that addresses that vulnerability, you have 4 months to get out an update. And same thing when it comes to functionality and OS updates, that they're looking for something to then be rolled out to devices within 6 months after the release has been made. So, all in all, this is something that starts to really change and create motivations for, taking into account security. Let's move on to the next slide. Okay, so all in all, why should you care? Why should we care as an ecosystem? Well, if anything, these laws do come with non-compliance fines. And so that, that monetary side of the equation definitely has an impact to, you and your products. However, even then, just ignoring that side of the law, in general, you don't want to have a cybersecurity incident. Nobody does. It's something that impacts your product and can impact your brand. Likewise, as we're moving towards products in the future, designing more secure products, is increasingly seem to be on something that's on everybody's radar. And it seems to be a point of competitiveness. If, your product's next to somebody else's product is, for, lots of reasons more secure, that can be something that makes your product stand out. But, within all of these, within all of this swirling set of things that you need to take into account when it comes to government mandates, another thing to consider is open source software. And open source software has taken on, or I should say, has in general had a good history of taking appropriate action when cybersecurity incidents happen. So, like for instance, the XE incident that just happened here very recently, the community has come together, and you see lots of examples of the community standing up, trying to do their part and do the right thing. And so as government mandates change and laws evolve, certainly the open source community is going to try to step up and do the right thing. Let's move on to the next slide. So Dan, take it away.
Thanks, Tom. This slide shows the LTS kernel from upstreamkernel.org. And as people update their kernels, this forms a starting point for everyone's kernel. The blue in this graph is the 4.19 kernel, and it's the oldest kernel that's still supported. It was released at the end of 2018. As you can see, we started with about 600 patches per month, and over time, that number has fallen to around maybe 200 patches per month. This graph is spikier than I had expected. I think that has to do with merge window cycles of upstream kernel. Even though the graph goes down, as time passes, the upstream and the older kernels diverge more and more. So the number of patches goes down, but the how complicated they are goes up. So they still need to be tested a lot. So you need to test the 600, you need to test the 200. And I'm going to tell a story about testing. In January, my manager got an email from Linus Torvalds that he had made Linus Torvalds' laptop twice as slow, his code. And that's a nightmare for anybody. And what I can tell you is that my manager had tested his software extensively. But unfortunately, the bug only showed up on certain older generation of Threadripper CPUs. And that's what Linus had on his laptop. So testing is very, very hard, and there's no substitute for testing on the actual hardware. And I'm going to say another story about testing, a maintainer secret, Linux kernel maintainer secret, which is that there's a certain percent of patches which are not tested at all. If you see a series of 30 patches that update 30 drivers to a newer and better API, that was tested on one driver, on one hardware. He doesn't have a lab with 30 different sound cards. And we're very good at those kind of cleanup patches. And we've done it a lot, and there are very few bugs. However, at the same time, we do rely on other people to test our software and to report back the bugs. So you do need to be testing LTS kernels. And you don't need to be testing just the blue kernel. You need to be testing the orange one and the yellow one and all the kernels. The kernel patches are like a river, which flows downstream from Linux Next to mainline to the LTS kernel. And you want to be as far upstream as possible. In the kernel, there's a rule that no regressions are allowed. And a regression is a bug, right? Obviously, all software has bugs. What the rule means is that if you make a change and it helps 10 people, but it hurts one person, then you need to consider the one person over the 10 people. But for that rule to apply, the one person has to be on the ball and reporting bugs quickly. And I report a lot of bugs myself. And from my experience, you want to report the bug before the original developer moves on to a different company or a different job or gets promoted. So testing is just absolutely essential. This graphic shows that there's a lot of patches and they all need to be tested if people are going to upgrade their systems, and they must now. Let's go to the next slide. This slide is about security vulnerabilities. In the new mandates, security vulnerabilities need to be addressed. But what is a security vulnerability? In practice, every security vulnerability gets a number called a CVE. And that process used to be handled by the MITRE Corporation. But recently, the kernel became a CNA, which means that they issue CVEs instead. And they get to decide if bug is security related or not. So if you look at a bug, it's very difficult to decide if it has a security impact. But the kernel developers felt like MITRE was being
Sounds like Dan is temporarily frozen there.
Okay,
maybe
pick
Tom,
it up.
you can just pick that up, and we'll
pick
see
it
if
up
that comes back.
from here, Bill. Yeah, so to kind of complete the thought here on this particular slide, so the kernel community as a CNA or a CVE number authority, they're issuing security vulnerabilities as they're discovered and having, of course, fixes that are associated then with those CVEs. And it will be, this system of measures. So basically, as a CVE is issued, you have a fix for that CVE that addresses that CVE. It is the government mandate that then will be tracking these CVEs and then be requiring you to make sure that that is, addressed within your software updates. Let's move on to the next slide. So let's summarize some of the points that we've made so far. First of which is we have, on the one hand, cybersecurity current concerns that are motivating governments to require, updates for operating systems and security fixes for, certain periods of time. 5 years is seeming to be the average, but it's not the only one. The patch counts from LTS kernels averaging about 600 per month. It's very spiky though, so it goes up and goes down. It's a lot of change. And in order to contain that change and in order to find regressions, testing now has become critically important. We need to do more of it. We need to have it be focused in particular areas for the variety of use cases that the Linux kernel is exposed to in various people's products as well as out in the community. We have, on the one hand, a new kernel community process, being involved with CVEs and being able to generate their own CVEs. And then on the opposite side, we have the kernel community, which has shortened the support periods for two of its kernels, 5.15 and 6.1 to 5 and 4 years. And now 6.6 as the new LTS on the block is just 3 years. And then of note is 5.10, 5.15, 6.1, and 6.6 will all go out of their support periods. So they're going to exit support on December of 2026. So they're going to all come out at the same time. All right, let's move forward to the next slide. Okay, so this is a good time to pause and think about, what should an LTS look like? And this isn't something that is a question that we should pose just to the Linux kernel. This is something that we should look at across a variety of projects, because obviously when it comes to open source software that goes into products, it's not just the Linux kernel, it's other things too. It's bootloaders, it's firmware, it's user space code, so on and so forth. And so, one of the, of course, most important things is that if you're going to be working in this LTS space, when the community ends their support, the people that would be working with fixed streams and stuff, you need an experienced engineering team who can pick up a patch and understand, does this patch apply? Is this something that's important? What is the nature? What does this impact? There's a bunch of things that they need to consider. Projects in general, for open source projects in particular, they really need to have a fixed policy in place that determines what can and what cannot go in. In the case of some projects, their fixed policy even allows new functionality to go into stable code. Some projects like the kernel are very more conservative, and again, they're fixes only, and they're very specific about that. And they say that when a fix goes into the project, it must be labeled as such in the actual commit, which is, again, makes it very important, especially for people who are going back and taking a look at the nature of fixes. You need a healthy stream of fixes, because a healthy stream implies that a code base is being used. People are, pushing it. They're running test suites against it. They're using it. And when you're using a system in such a way, that means you find bugs, and therefore those bugs needs to be addressed. We've talked, of course, about the security and the CVE system. So, of course, you need to have a system that tracks security issues, and you, of course, need to have the documentation that goes with those as well. Testing, we cannot emphasize this enough, and the testing needs to occur at scale. It needs to address not only functionality, it needs to think about things in terms of performance, so that a system cannot go slower or the power management doesn't get worse. Various attributes of the system need to be looked at. And so much of testing today, especially, for instance, in the Linux kernel, is only, does a test case pass or fail, as opposed to looking at things like latency or other kinds of issues. And another thing, which I think most of you on this call probably would strongly agree with, is all of this needs to apply to you. It needs to take into account your platform. It needs to think about the configuration that you use and the use cases that you are taking or are having in your product. Those use cases need to be tested in some meaningful way. Now, another thing that we haven't really talked about too much is that there are oftentimes key dependencies between pieces of software where, it's not the kernel just standing alone. It's the kernel plus firmware. It's the kernel plus firmware plus a bootloader. And then the user space that you boot into. All of these things actually matter, even when it comes to testing. All right, let's jump into the next slide. So this brings us into the Linaro LTS solution, and something that we've been designing for some time now. Moving on to the next slide. One of the things that we've observed is that, when it comes to an LTS kernel from kernel.org, especially when it comes to embedded products, people and companies, they just don't take a kernel as is. They do some amount of engineering on top of that. They might add fixes, they might add new functionality such as drivers. There's generally some amount of things that a company needs to do. And as I mentioned, they need to ship more than just the kernel. Obviously, when it comes to a product, the kernel isn't the end all be all of what goes into the product. All the other stuff matters too. So could go forward, please. So this brings us to a set of product needs. Generally speaking, when it comes to the 2-year default that the Linux kernel community has selected, 2 years isn't generally enough for support. That, that time does not cover the engineering, the product development, and then ultimately the time that a product will be for sale and needs to be supported through its lifetime. You obviously need to have more than just the kernel covered. You need to have, some amount of patch backporting and critical security updates that are taken care of, not only just for the 2-year support period, but for longer than that. Regression integration testing becomes very important, and it needs to take place on your hardware in the manner that you are using your product, or that your users will use your product. As you are having these tests run, those results need to be resolved. You will have a sea of data, and across all the various configurations that can be run, going through those results effectively, efficiently, and being able to ferret out what are, problems is important. Sometimes the littlest thing can result in what can be major problems in the system. And being able to look and being able to spot those things is critically important. And another thing that we find, especially when it comes to support for an LTS, is support for code that isn't in the tree yet. For whatever reason, it hasn't made it upstream. That oftentimes can take time, and we recognize that, and we need to be able to work with that. All right, so if you could advance forward. Okay, so the solution that Linaro is put together is one that is a custom tailored LTS. It's really something that takes into account what a specific company needs. We need to fit into your release cycle. We need to fit into the support period that you expect. And we recognize that you need support for more than just the kernel. For us, providing support for U-boot, which does not even provide an LTS, Opti-E and trusted firmware are key critical components that we are stepping up and providing LTS support for. Out of tree code support is something that we will do. In addition, we also provide consulting services, so we can take care of the uprevving, your upstreaming, and maintaining your out of tree code. So we will work with your engineering team and make sure that the best interest of that code, both in the community as well as supporting your engineering, takes place. We will, during the time that the community ends their support, we will pick that support up and do the patch backporting as well as the critical security fixes, and we will plug into your security process. So whatever information that your team needs internal to your company, we will make sure that they're supplied the information that they need to take into account as part of doing their security updates. We want a regression test not only on your hardware, but across a diverse set of hardware. So Linaro already has the LKQ program, what does quite a bit of testing on a wide variety of hardware. Adding your hardware into this mix is, of course, something that's very important. And we can do that with either the hardware being in our lab or remotely in your lab through something called the Lava appliance. And lastly, we would have support for custom test suites. We certainly triage the results and get that information not only to your hands, but also into the hands of the community, so that we will effectively let the community know not to ship a candidate patch if it breaks somebody for some particular reason. All right, let's move on to the next slide. Okay, so when it comes to LTS, Linaro is really looking for 4 main ideas of providing you value, one of which is expanded testing. So that's including your hardware and your test suites. Working with you in the case that you have code, so upstreaming and uprevving, we will do what needs to be done to get that code out into the community and have it accepted. So that can be a substantial burden, can take a lot of time, but this is something that we've worked with over the number of years, and we're fairly good at it, but we still need to work within the constraints of what the community will accept. We will extend the LTS, so we will work basically to pick up the LTS and support it where the community stops. Likewise, we do backporting. So in the case that there are critical fixes or other things that are out in the community that need to be shepherded along for whatever reason, we will look out for interests and also help to move that code so that it likewise is accepted either in mainline or into stable LTSs. Okay, so let's move to the next slide. So these are the four components of our LTS solution. It's the Linux kernel, it's trusted firmware, it's Opti, and U-boot. We've talked a lot about the Linux kernel in this session today. Trusted firmware is something where they've just gotten into having their own LTSs as a project, so it's as of version 2.8. In the case of Opti, we've been maintaining that since 2014, and so as the maintainers, we're in a unique position to maintain it and provide LTS support for it. In the case of U-boot, it of course is one of the very popular bootloaders in the embedded world, and it does not have any LTS support. So this is something that we feel that is very important to have as part of our LTS solution. Let's move forward to what should be the, I believe, the last slide before we move into questions, which is let's draw it all together and summarize some of what we've talked about today. So first and foremost, cybersecurity concerns, they really are motivating a lot of action, not only with governments and, companies that are creating product, but even open source projects as well. There's certainly a lot of change that is going to be confronting all of us. There are certainly a lot of things that are not necessarily well known, but we are starting to see some very clear trends, which is we need to all up our game when it comes to security, provide security fixes, and provide support for extended periods of time for our products. LTS and the kernel, these are critical software components in your product. And, together with the open source community, we all need to have a plan to address both functionality and security defects through the lifetime of products, as well as the lifetime of an LTS or even an extended LTS that you might turn to Linaro for. And lastly, Linaro is offering a custom tailored LTS solution. We really want to work with you and end up with something that meets your particular product needs so that you can be successful meeting not only your security obligations, but also quality obligations for your product as you base it on open source software. We've been a leader when it comes to kernel engineering and testing technologies, from Lava to LKQ and TuxSuite, and even something called the Lava appliance, which you may not have heard too much about yet, but we've been doing this since our founding in 2010, and we really look forward to working with you. There's a link here that you have a mechanism to directly contact us. So now let's open things up to Q&A. Back to you, Bill.
Hey, thanks, Tom. Thanks, Dan. Thanks for joining us again. So we have a few pretty good questions here. So I'm going to kick off with the first one, which has actually been asked by a couple of attendees. So I'll give you both wordings of the questions that we've got. The question is, will Linaro put the Linaro LTS source code on kernel.org? Effectively, is the Linaro LTS kernel fork something that's going to be private, or will it be public? Tom?
Okay, so in our case, as I mentioned, we're doing a custom tailored solution for LTS and specifically the Linux kernel. So it is a solution which is based on the LTS that the community has created. So when the community ends their support, so let's pick, say, like the 6.6 version, that means Linaro will pick up both the bug fixing and security fixing for that particular kernel series. And if there is, in the case of the company that we would be working with, a need for out-of-tree code, that out-of-tree code would then be mixed in with that particular kernel. So it is, again, custom tailored to them and their product needs. Posting that on kernel.org wouldn't really make a lot of sense because, again, it's something specific to that company and what that company needs. As far as, is Linaro trying to do a general purpose, LTS for anybody in the entire universe? That's really not something that we're trying to do. So hopefully that answers your question.
Thanks, Tom. Next question we have is, maybe this is either for you or for Dan. Will the LTS kernel ABI be stable so that binary drivers continue to work?
Yeah, Dan, do you want to talk about that one?
No, we don't look at that as a market that we want to be in. Like, if you can't recompile your drivers, you probably can't support your kernel for 5 years.
Okay.
Yeah, so there have been some efforts with, like, for instance, like libabigail and some other projects to try to maintain a stable kernel ABI, but that's, that's really something that's still experimental in nature, and there are some things which make that a very hard problem to solve. I mean, certainly, when it comes to regressions, be it either through LTS from the community or LTS through Linaro, we try to do the best thing. We're not trying to break, code in general on purpose. We're trying to do the right thing, but that's not to say that there can't be things due to the nature of a fix. Even for the purposes of security, where you have to take into account to address the security hole, you have to do the right thing and cause a change that might cause a break in the ABI and therefore recompile.
Okay, thanks, Tom. I guess probably need to pick up on questions because we've got quite a few to get through. One question, since one of the commandments of the Linux kernel is that backwards compatibility of user applications, i.e. not break user space, why not simply use the latest stable kernel instead of LTS?
So the latest stable kernel. So let's assume that you, as a product vendor, you were to choose the latest stable kernel and not even use LTSs. So the support period for the latest stable kernel is even shorter. And so that would mean that during the lifetime of your product, you'd have to do in-field upgrades of major kernel versions through the lifetime of your product. Can it be done? Potentially possible. Is anybody doing this? I'm not sure that anybody is quite yet. Certainly when it comes to LTS kernels, due to the support periods that are there, companies have either looked at or have done, in-field upgrades that way, but they do it after several years. And that's just due to the testing that's required in the engineering to make sure that they don't break their product.
Right, thanks, Tom. So we have a question about CVEs. Since it's not often obvious to determine whether a bug fix impacts security, it's expected that CVEs will be increasing in number and more difficult to backport a patch as the kernel gets older. Is the maintenance activity for each LTS kernel going to be unsustainable?
Dan, would you like to answer this question?
I feel like with the new mandates, there are going to be some companies which just leave the market. But of course, we feel like we can manage it. Yeah, but there are going to be some companies which cannot handle 5-year updates.
Yeah. So the community at this point, certainly the CVE process within the kernel community and becoming a new CNA is new. It looks to be about 20 CVEs per week, if I have that right, Dan. Correct me if I'm wrong. And that is quite a flow of change. And there is and certainly acknowledgement on our part that if you are going to take a CVE and apply that to an older kernel, that the chances are that the kernel has evolved its design or some other factors that will make backporting that fix very difficult. But on the other hand, you take a look at companies like, for instance, like Red Hat, where they do maintain their kernels for an extended period of time, and that is they're not they as well as us, we are all going to have to meet this this expectation.
Thanks, Tom. Next question, will Linaro support any kernel version that a customer asks for, or is there a predefined set of versions that will be supported?
Yeah. So the only versions of the kernel that Linaro will support through its LTS solution are going to be the ones that were LTS kernels to begin with from the community. So we're not going to just pick up a random kernel version, if you will.
Okay. And then we have a question. Does hardware testing require hardware to be in a Linaro lab, or can it be at a company site remotely driven by Linaro test infrastructure?
So in this case, Linaro has a great deal of flexibility. So because of the Lava automation appliance, we have the ability where hardware can be either in the Linaro lab or it can be on a remote site. And either one is something that we can work with. And we do have experience with companies that have very challenging firewall requirements. So we feel that we do have a good solution.
Great, thanks, Tom. And next question, how are you planning to do U-boot LTS for customers? Are you going to enforce policy that fixes will go up to upstream U-boot first before they can go into Linaro U-boot LTS?
Okay, so this one I want to back off and take a look at a kind of the bigger picture when it comes to U-boot, because I think there's sort of a twofold situation here, which would be ideal. So one of which is, what is in the best interest of the U-boot project itself? I think that's up for discussion, and certainly within the U-boot discussion, there has been, talk about having a U-boot LTS. It hasn't happened as of yet. Certainly within the U-boot project, we already know just from a project hygiene perspective that not necessarily all things are labeled as fixes. So that's something that, just as a project, we think working with them to kind of help make that better is a good thing and a good investment, not only for, Linaro, but really the world at large. Now for Linaro offering a U-boot LTS, we have to be very pragmatic. There will be what the community will do, but ideally what we would like is that it follows a policy very similar to the kernel, where fixes would be accepted by mainline first before then they would be ultimately picked up and included in our LTS. But likewise, as I mentioned, elsewhere in the presentation today, we do acknowledge the need for out-of-tree code for what can be very real reasons, such as hardware support. And, that is something that, bootloaders in particular can have to face. So, we do need to be able to be very flexible as a result.
Okay, we're coming to the end of the time slot now. I'll ask one more question. Will all the patches for Linaro LTS solution be from the main line, even for customer tailored functionality?
Okay, so there's probably we should dissect this question just a little bit. So when it comes to fixes from the community that have been authored, either by subsystem maintainers or what have you, those fixes are going to be landed on mainline first before that we would ultimately pick them up and include them in our LTS. Now, for a customer tailored situation where you have functionality that includes out-of-tree code for some set of reason, and that could even include some amount of fixes, the right thing for Linaro to do is to push those fixes out to the community for acceptance, but in parallel, be working with that customer and making sure that that customer is supported both with the fixes that they need and the functionality that they need, even though that's not necessarily included in mainline Linux. Okay.
Thanks, Tom. We've unfortunately got to the end of our time slot here for this webinar. I'd like to thank everyone for joining and actively participating. We've had some great questions. We still have a few questions that we didn't have time to get to. If you joined and you registered and we know who you are, then we will reach out to you with an answer to your question. If you joined anonymously, unfortunately we don't know who you are who asked the questions, so we ask that you use the contact us link to ask that question, and we will answer it with you one-to-one. I'd like to thank our speakers, Tom and Dan and the webinar team for putting this webinar together. But I'd really like to thank all of you for joining and participating. And please don't hesitate to get in touch with us via the links that we provide with the material. On that topic, we will share a recording of this session, and we will share copies of the presented material as well. Thanks for joining.